Alright class, here's a couple more examples on solving by factoring, and these are from the blue packet from, this is 9:30 solving by factoring. And so, remember today in class when we talked about, we used our little factor flow chart. First thing you want to do is ask yourself, is there any GCFs? Okay, so I see that my A value here, my value with the its squared term is not 1, so I need to see, is 3 a factor of B and C? So I see that it is, so I need to divide everything here by 3. So I'm going to divide 3, 3, and 3. So since I'm dividing by 3, I want to put that on outside the parentheses. So I'm going to 3 on the outside, and 3 divided by 3 is A. 12 divided by 3 gives me 4A, and then 12 divided by 3 gives me positive 4. Alright, so now that I have my A equals 1, then I'm going to do my little puzzle. Remember, we put C up here and then B here. So now that my A is 1, I'm going to put my C term here, and my B term here is going to be minus 4. So I want numbers, two numbers that's going to multiply to give me positive 4, but add to be negative 4. Okay, so my factors of 4, factors or numbers that multiply to give me 4 is going to be like 1 and 4 and 2 and 2. Alright, so how can I multiply to get a positive 4 and a negative 4? Well, if I multiply negative 2 and negative 2, I'm going to get a positive 4, and add them, I'm going to get a negative 4. So then this becomes, with a 3 on the outside, I have A minus 2 times A minus 2 equals 0. Okay, so there are my factors. So now I'm going to set these equal to 0. So I add 2 to both sides, and I get A equals 2, and A is equal to 2. So what does that mean? Okay, so now I have the same answer. So all that is telling me that instead of having 2 x-intercepts, I'm going to have 1 at 2. So my graph is going to come here and, you know, bounce there. Alright, so now I know that my x-intercepts is just at 2, 0. You can go ahead and write it down in 2, 0. That just tells me I have a double root, and we'll learn about that later, but that's what we call it, a double root. Okay, so now what is my y-intercept? Alright, my y-intercept is when x is equal to 0. So, or A in this case. I know they changed the variables up, but it's always whatever this term is. It's when the y-intercept is when I cross this axis, x is 0. Right there is 0. So I'm going to put 0 back into the original equation. And I get 3 times 0, 12 times 0. So my y-intercept is going to be 0. 0, 12. So my y-intercept is 0, 12. So if I graphed up here, you know, it's going to be up here. So now I have my y-intercept and my x-intercepts. Now I want to find my vertex, but I know my x-intercept right here looks like it's going to be my vertex. But just for practice sake, let's do it find the vertex. So my vertex, my x value of my vertex is equal to negative b over 2a. That's the formula that we use. Okay, that's been derived by all those old math people from a long time ago, so we're just going to go with it. It's a formula. The x value of vertex is negative b over 2a. So in my equation, my original equation was 3a squared minus 12a plus 12. This is my a, this is my b, this is my c. Alright, so I'm going to put negative b, so it's a negative 12, so that makes it a positive 12, all over 2 times 3. So that's going to give me 12 divided by 6, which is positive 2. So, okay, I already kind of knew that, but I just want to double check here. Sorry. So, now my x value is vertex is 2, so to find my y value, I plug it back into the original equation. Okay, so original equation 3a squared minus 12a plus 12 take my x value, plug it back into the equation. So I get 3 times 2 squared minus 12 times 2 plus 12. Okay, so now I'm going to do the math. This would be 3 times 4. 2 squared is 4 times 3 is 12. Minus 12 times 2 would be 24 plus 12. So 12 minus 24 is negative 24. 12, sorry, plus 12. And this is 0. So my y value, my vertex, so my vertex will be going to be 2, 0, but we kind of need that because it's my x-intercept. Okay? Alright class, so here's the second example. This is number 9 in the blue packet from the September 30th. So again, first thing I check to see is, do I have a greatest common factor? Okay, I know 12 multiplies into 24, but it does not multiply into 44. So now I need to look for a factor of 12 that I can divide out. So I know there are all three of these numbers are divisible by 2 because they're even. And then I know 3 is a factor of 12. Well, 3 goes into 12 and 24, but not 44. And I know that 4 goes into all 3 of them. So I'm going to divide everything by a 4. So I'm going to divide 12 by 4, 44 by 4, and 24 by 4. Alright, so put that on the outside of the parentheses because I'm dividing it out. 12 divided by 4 is 3n squared. 44 divided by 4 is 11n. And then 24 divided by 4 is 6. So that equals 0. Alright, so now there's nothing else I can factor out. Okay, so now I have to ask myself, okay, my a is not 1. So this is when we do that method where we're going to take 3 and we're going to slide him down here to the 6 and multiply. So I have the 4 here, and I'm going to bring down n squared minus 11n, and I'll multiply 3 and 8 and get 18. Okay, so now I have my a equals 1, okay, and I'm going to factor doing the puzzle thing again. I'm going to put C here, and I'm going to put B here. Alright, this is factoring when A is greater than 1. Alright, so now I want factors of 18 that multiply to give me positive 18, but add to be negative 11. So my factors of 18 are 1 and 18, 2 and 9, and 3 and 6. Okay, so I see 2 and 9. I know they add to give me 11, and I could multiply to give to 18. Okay, again, I need a negative here and a positive here, so I just make them both a negative and a negative. Then I'm going to satisfy this. I'm going to multiply to get a positive 18, and then I'm going to add to get a negative 11. Alright, so these are my new factors. So now I'm going to have 4 times n minus 2 and n minus 9 equals 0. Okay, so I can't set these equal to 0 yet because remember I multiplied by this 3, so I need to go back in and divide it out. I need to divide by my a. So I'm going to have 4 n minus 2 times n minus 9. I'm going to divide this by 3 and this by 3. Okay, this one here simplifies to n minus 3, but this one I can't simplify, so this is when we got to do that bottoms up, move it up here, move it up next to the n. So I'm going to have 4 times 3n minus 2 equal to 0. So now if I multiply this back out, I know I have the 4 out here, I would multiply and get this value, and then I would multiply the 4 and get this value. So now I'm going to set these equal to 0 and get my x-intercepts. So I have 3n minus 2 equals 0, and n minus 3 equals 0. So I'll add 2 here, add 2 here, and then I wind up with 3n equals 2, divide by 3. So n equals 2/3. Add 3, and I get n equals positive 3. So again, guys, keep this in mind that this is telling me that if I had my little, I'm crossing here at positive 3, and then 2/3 is like 1/3. Okay, so remember back when we had factored form and we found our y-intercept, we looked for the halfway point to find the x value of our vertex. Okay, finding the x value halfway between this point would be not much fun with this fraction. Okay, so that's why we find the vertex. All right, so before we find the vertex, let's write this out. Our x-intercepts are 2/3 and 0 and 3 and 0. Okay, so now what's my y-intercept? Again, my y-intercept is when x equals 0. So if I go back to the original equation, I have 12n squared plus minus 44n plus 24. If I substitute 0 in for here, I know that this is going to be my y-intercept. So my y-intercept is at 0, 24. Okay, so now we're going to solve for the vertex. So the vertex is going to be x equals negative b over 2a. My original b was 44, so it's going to be positive 44 divided by 2 times 12. Be 44 divided by 24. Okay, and if we wanted to find the fraction version of that, we can leave it as a fraction, or we can divide it out. And if we divided that out, okay, that would be 11 over 6. And I'm going to leave it as a fraction because the decimal keeps going on and on. Alright, so that would be my my x value, my vertex. My y value is going to be 12 times 11 over 6 squared minus 44 times 11 over 6 and then plus 24. Okay, so if we plug that into our calculator, you're going to find out that alright, so I'm going to find out that my y is like negative 16 and 1/3. Let me double check the fraction. Yes, so it's negative 16 and 1/3. Alright, so that would be my y-intercept. I mean my vertex. So my vertex is going to be at 11 over 6 and then negative 16 and 1/3. And if you want to find the decimal version, the decimal. So again, my x-intercept's at 2/3, 0, 3 and 0, and 11, 6, and 16 and 1/3. Okay, one last example. Okay, now I have two terms from that factoring flow sheet we have. For first thing we want to say is that do we have a common factor? Okay, 9 does not factor into 15. Okay, but I know that 3 does. 3 is a factor of both. And I also know that I have 2 x's here and 1 here, so I have an x in common. So I can divide everything by 3x. So 9 divided by 3 is 3, and x squared divided by x, I have 1 left. 15 divided by 3 is 5, and my x's cancel out. So since I divided by 3x, it goes on the outside, equals 0. Alright, so now I'm going to set these both equal to 0 to get my x-intercepts. Alright, so if I divide by 3 here, divide by 3, I get x equals 0. And then I'll add 5 here and add 5 here. And I get 3x equals 5, and then divide by 3, x equals 5/3. So those are my two x-intercepts. So my x-intercepts are 0, 0, and 5/3, 0. Alright, so what would be my y-intercept? Again, y-intercept is when x equals 0. If I don't know, 0, plug it into the original equation, and I get equals 0. So that tells me that I'm crossing the y axis at 0, 0. So I have an x-intercept there. So